Imagine you are lying down, the room is quiet, and your mind begins to wander into the stars above. Before we even begin, let me ask you something simple, yet profound. Have you ever looked up at the night sky and wondered, where does it all end? That question is where our little journey begins tonight. You are not here to memorize equations or to test your memory. You are here to settle in, to let curiosity gently lead you, and to allow the universe to wash over you like a soft wave. Welcome to the Sleepy Scientist. This is our shared space, a corner of the vast internet where science is not rushed, where curiosity feels calm, and where you and I can wonder together. I like to think of this place as a quiet observatory in the middle of the night. The lights are dim, the telescope is ready, and the stars are waiting. You do not need to take notes. You do not need to keep track of terms. Think of this experience as listening to a campfire story, only the campfire is billions of galaxies glowing in the distance. I know you came here with a question in your heart. Does space end? That is a question both simple and profound. It is the type of question that makes a child pause in awe, and it makes scientists spend entire lifetimes searching for an answer. Tonight, we are not chasing a quick conclusion. Instead, we are walking through the ideas, the images, and the feelings that this question creates. The goal is not to arrive, but to travel gently. Now, let me set the mood a little further. Wherever you are right now, perhaps you are lying down, or maybe you are sitting with a warm cup of tea. Take a deep breath. Let your shoulders relax. You are not expected to solve anything here. The universe has been here for billions of years, and it is not in a hurry, so neither should we be. As we begin, let the words feel like music. Let them drift around you the way faint starlight drifts through the dark sky. And before we go further, I want to know something from you. Where are you joining us from? I always imagine people listening from different corners of the planet, maybe from a small town, maybe from a busy city, or maybe from a quiet countryside where the stars shine a little brighter. Wherever you are, you belong here. You are part of this curious family, so settle in. Let the question stay in your mind, but not as a burden. Let it stay like a lantern that lights the path forward. The beauty of the cosmos is not only in what we know, but also in the gentle mystery of what we do not yet know. And as we begin, I invite you to simply let the story flow like cosmic background radiation, quiet, steady, and timeless. When we hear the word space, many of us imagine a giant, empty black canvas. We think of silence, darkness, and nothingness, stretching endlessly in every direction. But let me ask you a question. Is space really empty? Or is there something far richer and more surprising hidden in that word? I remember the first time I lay on my back as a child, staring at the sky on a clear night. I thought to myself, I'm looking into nothing. It felt overwhelming, almost like I was floating. But as I grew older and learned more, I realized that space is not just an empty box where planets and stars are placed. It is more like a living stage, constantly shifting, bending, and even buzzing with invisible energy. So tonight, let us peel away the idea of nothingness and see space for what it really is. To begin, let us step back in time. Long ago, scientists like Isaac Newton imagined space as a grand stage. Picture an old theater with wooden floors and velvet curtains. On that stage, planets, stars, and comets performed their roles, moving according to the script of gravity. The stage itself never changed. It was solid, unmoving, and eternal. That was Newton's view. Space as a background, a container that held everything. Simple, neat, and comfortable. But then, along came Albert Einstein. He looked at the same stage and said, "No, this is not fixed at all." Imagine that stage made not of wood, but of stretchy fabric, like a trampoline. Now, When you place something heavy on it, a bowling ball for example, the surface bends. If you roll a marble nearby, the marble curves around the dip made by the bowling ball. Suddenly, space is not just a passive backdrop. It is flexible, it bends, and it shapes the way objects move. This is space-time, Einstein's gift to our understanding of the cosmos. Space and time are woven together into one fabric, and massive objects tug at that fabric, creating what we call gravity. But the story goes even deeper. If we zoom in closer, far beyond what our eyes can see, the idea of emptiness fades even more. Quantum physics teaches us that no region of space is truly empty. Even in the darkest, quietest corner of the universe, there are tiny fields of energy, flickering and buzzing like invisible waves on a pond. Imagine standing at the shore of a lake early in the morning. At first, the water looks calm, but if you look closely, you see ripples, small disturbances moving across the surface. That is what the quantum world tells us space is like. Never. Perfectly still, always alive with activity. This means that when you stretch your hand into the air and say, "There is nothing here," you are in fact touching a sea of invisible fields and forces. You are reaching into a dynamic fabric that can expand, bend, ripple, and even produce particles out of pure energy. It is humbling to realize that empty space is one of the busiest, most active places of all. Now let me bring in a playful image. Think about your washing machine. Have you ever lost a sock in it? You place 2 socks in, but only one comes out. The missing sock seems to have slipped into some hidden dimension. That is, of course, a funny exaggeration, but in a way, space works like that too. It can curve and warp in ways that surprise us, sometimes hiding paths or stretching distances in ways our everyday senses cannot easily imagine. So what have we discovered so far? We began with Newton's stage, solid and unchanging. We moved to Einstein's trampoline, bending under the weight of matter. And then we dove into the quantum pond, where invisible ripples prove that empty is never truly empty. But let us pause for a moment. How does this make you feel? When I think of space this way, I no longer see it as cold or distant. Instead, it feels alive, like a vast ocean that carries us gently along. It makes me wonder if the very fabric of reality can stretch, bend, and ripple, then what else is possible? How far can curiosity take us when even nothing is something extraordinary? As we continue, I want you to hold on to this idea. The next time you look up at the sky, do not just think of a dark void. Imagine instead a giant invisible fabric stretching across the cosmos, carrying galaxies like lanterns floating on a river. Imagine that this fabric is alive with unseen energy, with tiny ripples of possibility moving quietly through the dark. That is what space really is. Not nothing, but everything. Have you ever looked up at the night sky and wondered, how far does this really go? We see stars, planets, maybe even a faint stripe of the Milky Way if the sky is dark enough. But here's the thing. The universe stretches much, much farther than our eyes, or even our best telescopes, can reach. Scientists call this part that we can see the observable universe. Think of it as the cosmic bubble we live in. It is not the entire universe. It is just the part that light has had time to travel to us since the beginning of time itself. Now let us break this down. What observable universe really means imagine. Standing in the middle of a huge field with a flashlight, the light spreads outward in all directions. If someone is standing really far away, they will only see the light after it travels all that distance. The universe works the same way, except the flashlight is the Big Bang, which happened about 13.8 billion years ago. The light from that very first moment has been racing through space ever since. And what we call the observable universe is simply the distance that light has managed to travel to us in all that time. But here is the mind-bending twist. Because the universe itself has been expanding as the light traveled. The edge of the observable universe is not 13.8 billion light-years away. It is actually around 46 billion light-years in every direction. That is a cosmic bubble almost 93 billion light-years across. Yes, you heard that right. 93 billion light-years. Why we cannot see beyond. So here is the big question. If the universe is infinite, or at least much bigger than our bubble, why can we not see past it? It is simple. Light has not had enough time. Beyond that 46 billion light-year horizon, the light from galaxies has not yet reached us. It is like waiting for a text message from a friend who lives across the world. The message is on the way, but it is not here yet. And just like that, we live inside a cosmic horizon, a limit of what we can see. Not because there is nothing beyond, but because the information has not arrived. What is inside our observable universe? So, what do we find inside this massive bubble? Billions of galaxies, each filled with billions of stars. Cosmic web structures, giant clusters and filaments of galaxies connected like a 3D spider web. Cosmic microwave background, CMB, the faint glow left over from the Big Bang. This is the oldest light we can detect, a baby picture of the universe when it was just 380,000 years old. And here is something fascinating. When we look deeper into space, we are not just looking farther in distance, we are looking back in time. The farther away a galaxy is, the younger it appears, because its light began its journey billions of years ago. So in a way, telescopes are also time machines. Mind-bending scale. Let us try to imagine this scale. If the Earth were the size of a single grain of sand, then our entire observable universe would be like a beach stretching across millions of miles. Or picture this. If you started counting every galaxy in our bubble, one per second, it would take you over 3,000 years just to finish counting. This is why many scientists say the numbers are so huge, they almost stop feeling like numbers. They become more like poetry. The edge of what we can know, now comes the mysterious part. What lies beyond our observable universe? We do not know for sure. It could be more of the same, more galaxies, more stars, more cosmic structures, or it could be something completely different, something we cannot even imagine. Some theories even suggest that the universe might be infinite, stretching forever in every direction. Others suggest we could be part of a much larger multiverse, where countless universes bubble up like foam in an endless cosmic ocean. But here is the humbling truth. As advanced as we are, we might never be able to see beyond our horizon. The universe may always keep some of its secrets hidden. Why this matters, you might be asking, okay, this is cool, but why should I care? Here is why. Understanding the observable universe is not just about numbers and distances. It is about perspective. It reminds us that we live on a small blue planet, orbiting an average star in just one galaxy among billions. And yet, from this tiny spot, humans have managed to map the cosmos, measure its size, and even capture the faint glow from its very birth. That is breathtaking. Final thought. So the next time you step outside and look at the night sky, remember this. Those stars are only the beginning. Beyond them is a web of galaxies stretching nearly 46 billion light-years in every direction. And beyond that, a mystery we may never solve. The observable universe is our cosmic horizon. It is the grand stage where everything we know takes place. But it also whispers a deeper truth, that what we see is only a fraction of a far greater story. And maybe that is what makes the universe so endlessly beautiful. Narrator, calm, deep, reflective tone. In the beginning, there was nothing. And then, in a single flash of unimaginable energy, space itself was born. From that moment, the universe has never stood still. It has been growing, stretching, expanding, carrying galaxies, stars, and time itself along for the ride. At first, the newborn universe was tiny, smaller than a grain of sand. But within a fraction of a second, it ballooned outward faster than the speed of light, a moment scientists call cosmic inflation. Out of this violent birth, matter cooled, stars ignited, and galaxies took shape. For most of human history, we believed the universe was eternal and unchanging. Then, in the 1920s, American astronomer Edwin Hubble made a discovery that changed everything. He noticed that the light from distant galaxies was stretched, shifted toward the red end of the spectrum. This red shift revealed a stunning truth. Galaxies were not standing still. They were racing away from us. The entire universe was expanding. But here is the most astonishing part. The galaxies are not flying through space like bullets. Instead, it is space itself that is stretching, carrying the galaxies with it. Imagine dots on the surface of a balloon. As the balloon inflates, every dot drifts farther from every other dot. No center, no edge, just endless expansion in every direction. The farther away a galaxy is, the faster it appears to recede. This simple relationship, called Hubble's law, gave birth to modern cosmology. It told us the universe had a beginning, the Big Bang, and that it is still evolving today. But then came an even greater surprise. In the late 1990s, scientists discovered that the expansion of the universe is not slowing down, it is speeding up. Something unseen, something mysterious, is pushing galaxies apart with greater and greater force. We call it dark energy. It makes up nearly 70% of the universe, yet we do not know what it truly is. If this accelerated expansion continues, the future of the cosmos may be bleak and lonely. Galaxies will drift so far apart that their light will never reach each other. Stars will burn out. New stars will stop being born. Over trillions of years, the universe will grow cold and dark, a silent ocean of space. Scientists call this fate the Big Freeze. Other theories suggest even stranger endings. If dark energy grows stronger, it could rip apart galaxies, stars, planets, even the atoms themselves. A final moment known as the Big Rip. In another possibility, expansion may one day reverse, pulling everything back inwards, collapsing into a big crunch, a new beginning hidden in an ending. Yet for all our equations, the truth is still unknown. The expansion of the universe is not just a scientific fact. It is a cosmic mystery, a reminder that we live inside a story still unfolding. Every second, the fabric of space stretches a little more, and with it, so does the story of us, fragile beings on a small planet, trying to understand an infinite, expanding cosmos. The universe is expanding, and so is our curiosity. Imagine stepping outside on a quiet night, looking up at the sky and realizing that every single star, every galaxy, every cluster of light you see is slowly drifting farther and farther away. The universe is not standing still. It is expanding. And this expansion is not just a piece of science trivia. It has real, profound consequences for everything that exists. So, what exactly are those consequences? Let us take a journey into the far-reaching effects of this grand cosmic motion. First, let us talk about distance. When the universe expands, galaxies are carried away from us like dots on the surface of a balloon that is being inflated. The farther away a galaxy is, the faster it seems to move away. This is not because those galaxies are flying through space at incredible speeds, but because the very fabric of space itself is stretching. Now, think about that for a moment. The space between us and the galaxies is growing. That means that light, which travels at a constant speed, takes longer and longer to reach us. The result? Distant galaxies look redder, dimmer, and older. This brings us to a fascinating consequence: the cosmic horizon. Imagine standing at the shore of an ocean. No matter how sharp your eyes are, you cannot see beyond the horizon. The same is true for our universe. Because of expansion, there are regions of the cosmos whose light will never reach us. They are simply too far, and space is stretching too quickly. This means there are parts of the universe that will remain forever hidden, sealed beyond our reach. Does that not make you wonder what mysteries are out there, locked away in the endless dark? Now let us zoom in on another outcome: the fading night sky of the future. Right now, when you look up, you see a grand tapestry of stars and galaxies. But as billions of years pass, that sky will change. Galaxies that we can see today will slip beyond the cosmic horizon. They will vanish, not because they disappear, but because their light will no longer be able to cross the ever-expanding gulf of space. Imagine future astronomers standing under a night sky that looks almost empty, unaware that once the universe was alive with countless galaxies. It is humbling and a little bittersweet, is it not? Of course, expansion also influences the life and fate of stars and galaxies. As space grows, galaxies become more isolated. Over immense timescales, stars within them will burn through their fuel and fade. The brilliant bursts of starlight that shape the universe we know will gradually dim. Eventually, galaxies will become quiet islands of ancient stars, drifting apart into the dark. Expansion writes this slow but inevitable story of cosmic solitude. But expansion does not only touch the distant skies, it also shapes how we think about time itself. When scientists study the universe, they are not just asking where galaxies are going, but what the future of the cosmos holds. Will expansion continue forever? Will it slow down or speed up? Right now, evidence suggests that a mysterious force we call dark energy is pushing the universe to expand faster and faster. If that continues, it paints a picture of a universe that never stops stretching. Every galaxy, every star system, every particle of matter will drift apart until even atoms are separated. It is an idea called the Big Freeze, where the universe grows so vast and thin that warmth, light, and activity become rare. But before you feel overwhelmed, let us pause here. Expansion is not just about endings, it is also about beginnings. Without expansion, there would be no galaxies in the first place. The early universe was a hot, dense soup, and as it expanded, matter cooled and clumped together to form stars, planets, and eventually, life. Expansion gave us the possibility to exist, to wonder, and to tell this story. So in many ways, it is both a creator and a sculptor of destiny. And there is something deeply human about reflecting on these consequences. Think about it. Our lives are so brief compared to cosmic time. Yet here we are, capable of understanding and even predicting the future of the universe. Does that not fill you with awe? It shows us how small we are, but also how powerful our curiosity can be. So the consequences of expansion are not just cold scientific facts. They are emotional truths. They remind us that everything changes. They show us that isolation, distance, and even silence are part of the universe's rhythm. And yet, they also reveal beauty, a beauty that comes from knowing we are part of, something that is still unfolding, something far larger than ourselves. As you stand under the stars tonight, remember this. The light reaching your eyes may have traveled billions of years across an ever-expanding sea of space just to meet you. That light is a messenger, carrying a story of where the universe has been and where it is going. Expansion is not simply a scientific detail, it is the very heartbeat of the cosmos. And so, the question becomes, how will you carry this knowledge? Will you see the universe as a distant, cold mechanism, or as a living story, one that you are a part of? Because in a very real way, every one of us is woven into the consequences of expansion. The stars, the galaxies, the atoms in your body, they are all shaped by this eternal stretching. And that is not just science. That is poetry, written in the language of space and time. Have you ever looked up at the night sky and wondered, where does it all end? Billions of stars, galaxies scattered across unimaginable distances. Yet the deeper question always lingers in the human mind. If the universe is expanding, then what lies beyond its edge? Or is there even an edge at all? Let us take a journey together. Imagine yourself standing at the shore of an infinite ocean. Waves stretch out endlessly in every direction, and no matter where you walk, there is only more water. The universe works in a similar way. When scientists say that the universe is expanding, they mean space itself is stretching, carrying galaxies with it like raisins rising in dough. But here is the fascinating twist. There is no physical wall, no boundary, where it suddenly stops. Instead, the expansion is everywhere, and we are all part of this cosmic flow. Now, expansion itself brings questions that shake the imagination. If space continues to stretch forever, what becomes of the galaxies, stars, and even us? Over billions and trillions of years, galaxies will drift farther apart, so far that their light will no longer reach one another. One day, the Milky Way, our home, might be alone in the visible night sky. Can you imagine a future where the universe feels empty and silent, a sky with no galaxies shining beyond our own? This is not a tale of loss, but rather a powerful reminder of the rare moment we live in. Right now, we exist in a golden age where the universe is still visible, still connected, and still speaking to us through light that has traveled for billions of years. But what about the edges? Human curiosity has always loved edges. The edge of the map, the edge of the sea, the edge of human endurance. With the universe, though, the idea of an edge is slippery. There may be no edge at all, because space is not like a box with walls. It could be curved like the surface of a sphere. If you travel far enough in one direction, perhaps you would return to where you started, like walking around the Earth. Or maybe space is flat, stretching endlessly with no return. Which version is true? We do not yet know. And that mystery is what keeps our imagination alive. Some thinkers even propose that our universe may not be the only one. What if beyond the reach of our cosmic horizon, other universes exist, each with their own laws of physics, their own galaxies, maybe even their own version of us? This concept, called the multiverse, sounds like science fiction, but it is seriously considered by modern cosmologists. Does that possibility excite you? It certainly excites me, because it means our universe might not just be infinite in size, but also infinite in variety. Now, let us turn to the human heart. Why does this idea of infinity and edges matter to us? Because deep down, we are all explorers. From the first time a child looks at the stars and wonders, what is out there, to the great voyages across oceans, human beings have always been drawn toward the unknown. The expansion of the universe is the ultimate unknown. It tells us that the story of existence is still being written, and we are part of the chapter where discovery is possible. Think of it this way. When you stare into the night sky, you are not just seeing twinkling points of light. You are looking across time itself. The stars are messages, postcards from billions of years ago, carried across the expanding sea of space. And while future generations may live in a darker universe, cut off from distant galaxies, we are here now, living in a cosmic moment that lets us witness the vastness in full glory. That is a privilege worth pausing to feel. So, what lies ahead? If the expansion continues forever, time itself will feel endless. New stars will form, old stars will die, black holes will fade, and eventually, the universe could grow so stretched that matter itself becomes rare. This idea can sound overwhelming, but there is also beauty in it. Expansion does not just mean distance, it also means possibility. New regions of space, new physics, perhaps even new forms of life waiting to rise in corners of the cosmos we cannot yet imagine. But let me ask you this. What if expansion is not eternal? What if, after eons, gravity pulls everything back together in a grand cosmic cycle, leading to another beginning? Some scientists call this the Big Crunch. Others imagine a big bounce, where the universe may endlessly expand and contract, like breathing on a cosmic scale. Which would you prefer? The endless stretch of infinity or a cycle of rebirth? There is no wrong answer, only endless wonder. As we stand here on a small blue planet, thinking about edges and infinity, we realize something very human. The universe is not just out there, far away. It is inside us too. Every atom in your body was forged in a star that exploded billions of years ago. The expansion of the universe is not a distant event. It is a story we are woven into. We are not bystanders. We are living evidence that the cosmos creates, expands, and evolves. So the next time you look up at the stars, remember this. The edge you are searching for may not be at the end of the universe. It may be in your own imagination, your own courage to ask, what comes next? That is the true gift of infinity. It teaches us not to fear the endless, but to embrace it, to wonder, and to keep seeking. After all, without questions, what would drive us forward? Have you ever wondered what the universe looked like when it was just a baby? Imagine being able to see a photograph of your own childhood, not from your family's photo album, but from the very fabric of time itself. That is what scientists have done with the discovery of the oldest light in the cosmos, known as the cosmic microwave background radiation. It is a silent whisper from the universe's earliest years, a kind of fossilized glow that has traveled across billions of years to reach us today. When the universe was born in the event we call the Big Bang, it was not immediately full of stars, galaxies, or planets. For hundreds of thousands of years, it was a hot, dense soup of particles and light, all tangled together in a glowing fog. But about 380,000 years after the Big Bang, something magical happened. The universe cooled enough for atoms to form. Light could finally travel freely without being scattered by endless collisions. That very first light has been stretching and journeying across space for nearly 14 billion years, and today it arrives to us as faint microwave signals. If you could tune your old television set between channels, that soft static noise you would hear, a tiny fraction of that noise actually comes from this ancient cosmic light. Think about that for a second. Something as ordinary as static on a television carries within it a fingerprint of the birth of everything we know. The discovery of this ancient glow was like finding the universe's baby picture. It confirmed theories that scientists had imagined but had not yet proven. It told us that the universe truly began from a hot and dense origin, and that it has been expanding ever since. But beyond confirming what we thought we knew, this oldest light has also invited some of the wildest theories ever considered. Let us pause here for a moment. I want you to imagine yourself sitting on a quiet night, gazing at the stars. Every single star you see is just one point in the vast sea of galaxies. And hidden behind those galaxies is this faint glow, this ancient afterglow of the Big Bang, still reaching us across unimaginable distances. How small does that make us feel? And yet how connected? It is almost as if the universe is whispering to us across time, saying, I was here long before you, and I will continue long after. Now, What do scientists do when they encounter such a cosmic treasure? They start asking bigger, wilder questions. For example, could the universe we live in be just one among countless universes? Some theories suggest that our universe may be part of a vast multiverse, each with its own laws of physics, its own possibilities, and maybe even its own versions of light and life. Others look at the patterns in the cosmic microwave background and wonder if they could hold secrets about dimensions beyond the three we move through daily. Imagine for a moment that reality is like the surface of a vast ocean, and we are just drops riding the waves. Could there be entire worlds beneath the surface that we cannot yet see? The very idea excites the imagination and pushes us to dream beyond what feels possible. And then there are questions about the ultimate fate of the universe. Will this expansion go on forever, with galaxies drifting further and further apart until even the closest stars fade from view? Or will gravity, in some mysterious way, gather it all back together again in a grand cosmic embrace? Theories like the Big Freeze, the Big Crunch, and even the Big Bounce are part of the discussions, each one daring to predict how the story of everything might end, or perhaps begin anew. But what I find most powerful is not just the science, but the human reaction to it. Think about the sheer curiosity it takes for people to look at a faint, almost invisible glow in the sky and ask, "What is this? What does it mean?" That curiosity is deeply human. It is the same spark that makes a child ask, "Why is the sky blue?" Or an explorer sail into unknown oceans. It is a reminder that within each of us lives a desire to understand, to connect, and to make sense of the mysteries around us. When we talk about the oldest light and the wildest theories, we are not only talking about physics, we are also talking about our shared story as human beings. We are beings who wonder, beings who reach, beings who do not settle for what is visible, but dare to seek what lies beyond the horizon. So the next time you look up at the night sky, I invite you to take a quiet breath and reflect. Somewhere above you, across every direction, faint photons of ancient light are still traveling, carrying with them the story of the first moments of creation. You are not just looking at stars, you are looking at time itself, painted across the heavens like an invisible canvas. And that is a reminder that we too are part of this vast story. Perhaps the greatest wonder of all is not that the universe is expanding, not that there are theories about multiverses, or even that we can measure the oldest light. The greatest wonder may be that in a small corner of this immense cosmos, life arose that could ask these questions. Life that could wonder about its own origins. Life that could listen to the whispers of the universe and feel awe, humility, and joy all at once. So, what do you think? When you imagine the universe speaking through its oldest light, what do you hear? A warning? A comfort? Or perhaps an invitation to keep seeking, to keep dreaming, to keep reaching for answers just beyond our grasp? After all, the story of the universe is not finished. It is still unfolding, and we are lucky enough to be part of it. As we come to the end of this journey, let us pause for a moment and really feel what the expansion of the universe means for us. Think about it. Every night, when you look up at the sky, the tiny points of light you see are not just stars. They are entire galaxies, billions of them, quietly moving farther and farther away. The universe is not a still painting. It is a living, breathing story that keeps unfolding. What is even more fascinating is how this cosmic motion connects to our own lives. Have you ever noticed how time feels different in different moments? Sometimes a joyful day feels as if it passed in minutes, and sometimes a quiet evening feels endless. The universe is expanding in a way that almost mirrors this rhythm of life. Change is the only constant, whether in the stars or in our hearts. I often wonder, what does this endless expansion tell us? Perhaps it reminds us that there is always more to explore, more to learn, and more to imagine. Just as galaxies keep stretching into the unknown, our curiosity should also keep expanding. What questions will the next generation ask? What mysteries will they solve? Could one of you listening today be the person who discovers the next great truth about our cosmos? The expansion of the universe is not only a scientific fact, it is a gentle reminder that growth is natural, exploration is beautiful, and our place in this cosmic story is meaningful. So next time you see the night sky, do not just see darkness sprinkled with light. See a living universe inviting you to dream, to wonder, and to feel connected with everything around you.